Thank you, Guy. So yeah, let's get started. We're gonna here. I want to talk about how to build AWS serverless applications with Terraform. Uh, the the goal here is I'm going to just discuss a little bit of the theories like Terraform and serverless and how they match together, and then we're gonna dive into a cool demo. So my name is Andre. I'm originally from Brazil, and now I'm living in Berlin for around 5 years. And I'm a solutions architect by AWS and certified by AWS, and also finally got my Terraform Associate certification. And also, from time to time, I write some blogs, and if you want to check it out, it's in Medium, but I will also finally create my own, hopefully. And also my GitHub, where this project is also going to be there. So yeah, we all know that serverless is basically all applications that we don't have to manage, neither provision nor manage infrastructure. So in AWS, is every service that you just click and use, basically. So API Gateway, DynamoDB, Lambdas, SQS, SNS, and so on. And the advantages are you don't manage infrastructure, it's highly available, it's scalable, and zero idle capacity. This means that theoretically, all the infrastructure allocated for that service can be used by you. But yeah, at the same time, serverless has like some drop points that it can become really complex because you have like a lot of services and a lot of connections together, and this can become confusing. And even if you have to just use the AWS console, it can be hard to understand what you're dealing with and how your architecture is organized. So for example, this is an example of a classic approach where you have a server, you have a database, and have, for example, a mail service here down below. And if we are going to convert this to a serverless application, you would have something like this: an API gateway, two lambdas, one for getting and creating data, a DynamoDB, and then you have like messaging queues and publishers, another lambda, and SES, for example. The architecture itself can be different and have like many connections or different services, but the idea is that you will have a lot of services connecting together, and this can become quite confusing and hard to maintain. And that's where the advantages of Terraform come to help us manage these serverless applications. So if we don't use Terraform, we're going to have like a large number of services, repetitive actions, because you have to, for example, if you have to create 5 lambdas, you have to interact with the console 5 times at least. You are prone to have a lot of provisioning errors because we are humans, and if you have to do repetitive actions, it's probably going to have something wrong going along the way. Connections can become quite complex and hard to understand later on the maintenance steps, that what is connected to what. And you might also have a lot of spread services. While if we have with Terraform, we're going to have the amazing code reusability. And if you have to create like five lambdas, we can have a module, and then in pretty fast you can provision 5 lambdas. Faster provisioning, less provisioning errors because we are removing the human factor, and then we are using automation on top of that. We are organizing our services because it's going to be all documented in a repository for you, so you understand what are the connections and what are the services that make part of your application. So for example, if you have to provision 5 lambdas, you will have to write something like this code 5 times. And then if you get a module, you just have this. And if you have to provision more lambdas, you have like 3 modules, which is amazing. You reduce a lot of code, and with the automation itself, it's become really, really easier for you to provision services. Also, for the self-documentation, you would have something like this on your repository. For example, you have like an IAC folder, like with your modules. all your APIs, your buckets, Lambdas, providers, and all the services that are related. You are organizing it correctly under your code. So now it's the interesting part. Let's have some demos. Okay. Here I have 3 Lambdas for movie management. I have one here for creating data. So it's basically, I will interact with DynamoDB. I will get an event from API Gateway, and they will just add to DynamoDB. I have one for getting data, which is basically getting data from DynamoDB. And I have one here for email notification, which will get an event and process all the records that are in this event and dispatch an email through SES. You can see here. So how do we get started with our IAC? I have here 3 modules for this demo. So I will get this one here with the IAC folder. And here I have a module for Lambdas, one here for getting data sources, data blocks. So one for archiving a file, policies. And here I have overriding policies if I want to get more policies on this. I have an initialization code because you cannot provision Lambdas without a code. Even if you go to the console and click on create a Lambda, it will give you an initialization code. And this is basically a boilerplate code. We have variables for a Lambda, one for the name, environment variables, and policies. Outputs, which is the information that we might need outside our module. And it's very important because inside our module, everything is contained there. So anything that is created there, any variables that are defined there, it's inside the module and belongs only to that domain. If you want anything to interact with that module to be able to get information from it, you need to have outputs. And if you need to get information inside the module, you need to have variables, which are inputs. And here, basically, we just have a create an IAM role for this Lambda and give the policies and recreate a Lambda here for now with Node.js 22. And here we pass the handler, which is the index with the file, and the handler is the method that's going to be invoked. And okay, here we also have a module for REST API. That REST API method, because we are going to be creating multiple methods from our API gateway. So the method, it doesn't have an authorization for now, and all the boilerplate code for creating a method. So here, the post for a Lambda, the AWS proxy, because we want to pass everything down, and some permissions to invoke Lambda. And here's some throttling, because it's a demo, and we don't want to be able to be prone to a lot of requests by mistake. We have here a DynamoDB table, simple, and some seed data. Our Lambdas, just getting a module here. IAM policies to get data from DynamoDB, and the REST API. Pretty straightforward. And for getting started and configuring Terraform, I'm using the version, we get the Terraform block, put required providers, AWS, getting here, and the minimum version. And here I'm setting up a backend as free because we don't want to be using the local backend. Or else, yes, we are going to be using CI/CD. You're probably not going to get the same machine. Even more in GitHub Actions, which I'm going to be using, you're not going to get this same machine that you created the first. So every time you try to create it, Terraform will default to the local backend, and then it's going to try to create everything from scratch because it cannot find the state. And then you're going to get conflict errors. And here, just some variables. Okay. And to deploy, I have a simple GitHub Actions workflow here for deploying infrastructure. On push or workflow dispatch, it's going to be working on this folder here, IAC. Here I have my some secrets. So if you want to get variables inside Terraform, you can prefix everything with tfvar and then the variable name, which is here is account ID, and here our variables that we want. Here is region or account ID. Region is being picked up by variables.tfr. Then we just check out the code, initialize AWS, set up Terraform, initialize the code, format, plan, and then just apply everything. Okay, so what I'm going to do, I'm just going to push it, get first code. Yeah, doesn't matter here as it's a demo. Ideally, it would be a better commit message, but yeah. So here, we're going to have here in GitHub Actions, setting up, initializing. So here is where all the modules and providers are downloaded. And our plan, ideally, we would have a approval step between plan and apply, because then we can analyze our plan and make sure that everything that we want to change, delete, or create is in order with what you've written and what you want. Okay, so, and if I go now to the console, you can see that I will have here in API Gateway, I have my API here. And in my Lambdas, I have my Lambdas here, my Lambda for getting movie. And if I go to stage, I can go to this stage here and get the invoke URL. I'm just going to get this one here because I have an HTTP for getting data. If I send this request, you can see that I have hello from Lambda. Why? Because it's the initializing code that I got. And I don't like to have mixed my application code with my Terraform code. So as you can see here, my Lambdas are not deployed with my Terraform code. They are deployed using GitHub Actions, where I just use AWS CLI. It's just a matter of preference that I like to keep my code, my application code separated from my infrastructure code. So I can just go back here to Actions and then deploy this one here and just run this workflow. Thankfully, the deploying a Lambda is much faster than creating the infrastructure. So obtain the code. And if I go to this one here, I should have the new code. And if I try it here now, you can see that I get one of the seed data that I have. Okay, we can get data. And now we will start to create data. So I will add some policies for put item inside DynamoDB. So I get this one here, and I go to IAM policies here. I will create a new Lambda. So you can see here that I will just reuse a new module, which saves a lot of time. And I will just here, I will create a new endpoint, which is going to be this one here. And I go here and add it here. So you can see here, I'm just creating a new endpoint and then adding here to the trigger, because here it's going to, every time something changes here, it's going to trigger a new deployment, and then it's going to be live. I can just go here, stage, add create data, and synchronize. And then when I go back to GitHub, you can see I already triggered deployment of infrastructure. So it's creating the plan. And you can see everything that is going to be changed here, created, and then applying. So if I go to functions here, I should see my create movie function. Here, and then I can also test it. I have another one here, which I just need to get this. So to test, missing authentication token because not everything is deployed yet. Yeah. So you can see that hello flow lambda. Pretty simple, pretty straightforward, and pretty fast. Now I can go and do the same and deploy the create movie lambda. Just build, zip everything, and deploy. One thing to keep in mind is that if the deployment code is big, like above, I don't recall how many megabytes, but if it's too big, you need to do the deployment like I'm doing here through S3. I'm doing here just pushing the code direct to the Lambda, but you would have to push to S3 and then invoke, tell the Lambda, so yeah, my new code is in S3, please update it. So now I can go here and send this request again. And you can see I created this, received this response. And to make sure that I actually created something, I can go here and instead of using 1, I can put the new ID that I got and send request. And you can see that it actually created some data. Okay, and now for the last step this is one of the coolest parts. We're going to add email notification here. So what's going to happen here? So we're going to get here. So it's inverted. The created data is below. Sorry about that. So it's the create data is going to trigger SNS. That's going to push this message to SQS, and then the email notification lambda is going to pull the data and trigger SES. You could do this many different ways. Like SNS could directly push a message to push email directly to the consumer, but this is just one approach that you can take. You can have many approaches when dealing with serverless. Okay, so now we're gonna start by getting some policies here. So we're gonna give publish access to the Lambda function. We're gonna give receive and delete and get queue attributes for the email notification on the Lambda function. The email notification Lambda function also need to have permissions to send email to SES and to the identity and configuration set. It's very important. If you just give to the identity, sometimes it doesn't work. You need to give also to the configuration set. So I can get this one here, IAM policies, and add it here. We're gonna just create another Lambda here for email notification. So here, email notification. This is okay. And you can see here that we adding the SQS queue as a trigger to the email notification Lambda. This is very important, or else you cannot add as a trigger. Messaging. Oh, sorry, this one is. This here we're gonna create a topic, an SNS topic, a SQS queue, and then we're gonna give access for the SNS topic to push messages inside the SQS queue. And here also is very important because you need to create the SQS queue ARN by hand, because we are creating a policy and giving this policy directly to the SQS queue. And you cannot just come here and put AWS SQS and then the ARN here, because then you're gonna get into a loop. Because we are using implicit dependencies, and if this one is going to be tried to be created, but then this one needs it, and is also needed here. So you create a loop, and Terraform cannot create it. So you need to create this by hand. Okay, let's give some variables here for email identity and destination email. These variables here, why I'm doing this here, I'm going to just get a temporary email here. And here, email. We are creating the email identity. You could also use domain identity. I'm just using email identity because it's the easiest and simpler way to do this. And just one configuration set, which you just add rules for monitoring and other things that are cool to be using. So I got this email here. I will put in my variable here. Oh, sorry. Just close, cancel. Lambda doesn't need to save it. And it's in variables.tfr. Oh, sorry, this one here. I will just put this email here and then put it here. So I think I put everything: email, policies, lambdas, messaging, and variables. Okay. So now we push it, add email notification. And then here. So you can see that if I was doing this by hand, how many steps I would have to take just to create all these services. And if I have to understand which one is connected to what, I would have to click around the console many times. So for example, if I wanted to understand, okay, I have my SQS queue here, but okay, what is connected to what? So you would have to click around, trying to understand everything. But then you have like, oh, you have a subscription. Okay, you would have the subscription here. And aside from Terraform, you can just go to your code and say, oh, okay, I have here messaging, and I have everything connected here. So from our developer's point of view, it's much simpler to understand what's happening through here and see what's connected than just clicking around to the console. And it gets even worse when you're dealing with multi-account or multi-region, because then you need to be changing regions or accounts, and we all know how confusing it can get. Okay, so added here, and you see that I received an email here. Is just to confirm the identity. Just need to click here, and then congratulations, you are confirmed. And then I just need to deploy the Lambda. And I think okay. Deploy the email notification Lambda. And also in SES, we can check it here. Simple email notification, email service. You can see that I have the identity here. Yeah, and is also verified. Yeah, Chrome is not being nice to me today. Okay. Yeah, deploy the Lambda, and then I can go here, and I can just send this request again. It's going to create one, and I should get an email here as soon as this loads. And as you see, I got a new email here that's saying that a new movie was added. Pretty straightforward. And under 20, 30 minutes, we got a full application running, serverless application running in AWS using Terraform. And yep, that's it. Thank you for attending. I hope you liked it. And yeah, thank you.